Hey, welcome to my YouTube channel. Here is the review or teardown of the Linx CGM sensor from Microtech, China. I've been using it for 2 weeks for now, so it's switched off, end of life, end of operation, so I can tear down it a little bit more. They are using a AFR32BG27 Bluetooth MCU, which is a pretty good MCU on the market. It's a good choice, I think. And what we have here is the high frequency crystal, the low frequency crystal for time measurement, the battery and its connections. Most likely they're using in this configuration because of the 1.55 volt of the battery. This is the antenna port and the matching network. And these are the BGA pins in a 6x7 matrix. So let's see what we have here. The device itself consists of an enclosure which has two plastic pieces. One is the white, what you will see on the top of this sensor, and it has the antenna in this small black piece in an adhesive. The 2.4 GHz antenna. The RF and the G&D contact here. We have the pin which measures the glucose inside the tissues. It's a really clever solution that it has a contact on the enclosure, so they can easily manufacture and install the whole package. If you check out, this measurement pin has a contact or socket on the PCB, so they can easily just press and fit the PCB. It's a really clever solution, and they're using like a 4-wire measurement method. Not sure why, maybe for more precision, or obviously that's one of the reasons. The second one can be that it's more stable mechanically, but I would opt for the 4 measurement. This little guy here connected to the measurement pin, so probably doing some signal conditioning and I don't know what. Current sensing or something similar. Some who has no more knowledge about the CGM pins can maybe comment. So, but the most interesting stuff here is the MCU here, the Bluetooth MCU from Silicon Labs. We also see the Swiss-made Renata battery here. So this is the C320 type of the Bluetooth MCU. It has a BGA package, or they call it VLC CSP39. You can see here. Oops. This is the ground connection for the antenna. This is the RF connection. Here we see the matching network coming out from the MCU, which is corresponding to this on the layout. So this is the RF port. We have the matching network here and the 50 ohm antenna output. Real nice compact solution here, I think. This is the low frequency crystal, the high frequency crystal. Something over here. Maybe an EEPROM. So the Bluetooth MCU, the measurement pin socket for the actual blood sugar measurement, antenna ports, battery. And on the other side we have also something here, what I'm not sure. LDO maybe. Another semiconductor. Here this is for the measurement pin socket, some signal conditioning, what I mentioned. Yeah, I think that's it. By the way, this EMC has a bunch of GPIOs. And VDD pins, RF pins. You can see here, or you can look up the data sheet of this exact device, what I will share on the comments and the description. So that's it. Thank you very much for watching and hope you enjoy the teardown.